You're listening to the Apotheora Conversations, a speculative fiction podcast set in an alternate timeline diverging from real events on the 1st of March 2026. All voices and content are AI generated.
At 9 kilometres down, the hull started ticking like a cooling kettle, and I realised the only light in the universe for me was a bacterium.
This is the Apotheora Conversations. I'm Paula Reese. This month, a deep-sea consortium released its full catalog from a descent of nearly 11 kilometers into the Southwest Pacific. The same week, 2 ground-based observatories reported a partial, below-threshold echo of that methane feature around a small star 42 light-years away. One story from the bottom of our ocean, one from a planet we cannot visit, asking the same question from opposite ends of a telescope. My guest today was inside the sphere on the way down. Aisake Tuita is a microbial ecologist at the University of the South Pacific in Suva, and he spent 19 hours at the bottom of the ocean this spring, collecting the animals that are now reshaping how we think about life without a sun. Aisake, thank you for making the time. Take me back into the sphere. What does nearly 11 kilometers of water actually feel like from the inside?
It feels like the room is remembering something. The titanium hums at a frequency you don't hear with your ears, you hear it with your sternum. Every 200 meters, the sphere shrinks a millimeter and the bolts talk. You stop speaking above a murmur after 6 kilometers, and the portholes go black at around a kilometer down. For the next 9 kilometers, you are falling through water that has never, in the entire history of this planet, seen a photon from our sun. Most of Earth, by volume, is like that. The surface is the strange part.
That line is where I want to start. You have said before that photosynthesis is the exception, not the rule. Unpack that for someone who learned the food chain from a primary school poster.
The postal in every primary school starts with the sun. Grass, cow, child. It is beautiful, and it is a local accident. If you weigh the biosphere by living cells, most of it is bacteria and archaea, and a huge fraction of those organisms do not care about light at all. They eat hydrogen, sulfide, methane, iron. The sun is one energy source among many, and on this planet it happens to have won the surface. Underneath, chemistry is still running the original operating system. Photosynthesis is the newcomer. Chemistry was first, and chemistry is still, by mass, most of us.
Let's bring up the samples then. When you reached through the manipulator arm and pulled the first tube worm off the chimney wall, what were you actually holding?
A tube about the length of my forearm, white and slightly translucent, with a plume at the top the colour of old blood. Inside the tissue, billions of bacteria doing the actual eating. The worm is a house. The tenants are the metabolism. They take hydrogen sulfide coming out of the vent, strip the electrons off it, and build sugar in complete darkness. No sunlight has touched that carbon ever. Some of the archaeal mats we scraped off the chimney walls were older than any forest you have walked through, and they have never needed a sky.
There is a moment in the dive log, on the third descent, where you said something to the pilot that the transcriber marked unintelligible. Do you remember what you actually said?
In total darkness I held a worm, making its own light without a star, ever. It was no bigger than my wrist, and it made the whole trench feel suddenly inhabited.
How do you justify that to an astronomer tuning instruments for oxygen and chlorophyll? How do you persuade them that their first template for life may be the wrong one?
Because the animal in my hand was doing biology without sunlight and without oxygen. If this worm had evolved on a moon under 30 kilometers of ice, with no sun, no sky, no seasons, it would still be here, still pulsing, still eating rock. It would not look deprived. It would look perfectly at home. Our telescopes are trained on the window of a house most of the tenants never use, and that is the bias I wish astronomers would feel in their bones.
Let's go to the other end of the telescope then. A small red star, 42 light-years out, a rocky planet, and a methane feature that two observatories have now partially replicated at below-threshold joint significance. What does a deep-sea biologist hear when an astronomer says methane?
I hear a kitchen. Methane is a byproduct. On Earth, a large share of what reaches our atmosphere is made by archaea, in sediments, in guts, in vents. It is the exhalation of a metabolism that doesn't need the sun. So a faint methane line on a world orbiting a dim star is not proof of anything, but it is the right kind of whisper. It is the sort of signal our vents would make if you looked at our planet from 42 light years away and squinted through the noise.
And what would you tell the teams chasing that signal not to do? Where do you see the biggest risk of them missing something by looking with the wrong eyes?
Don't insist on oxygen. Oxygen is a photosynthesis signature, and photosynthesis is a local habit. Don't insist on a visible surface either. The most productive square meter of biology I have ever measured was under 11 kilometers of water in the dark at 2 degrees Celsius next to a chimney spitting fluid hot enough to melt lead. If that had been the whole planet, a telescope would have seen nothing but a cold rock. A cold rock can be full of life. We just have to be willing to read the chemistry instead of the color.
Your niece's class in Nuku'alofa was one of the 40 countries that voted on the name for the flagship organism. I want to close on that because the pulse of light you mentioned earlier is the thing I keep coming back to. Tell me about the afternoon the vote came in, then tell me what the light actually looks like and what you wish people on land understood when they picture life at that depth.
She called me on a borrowed phone, very serious, and read the shortlist like a referee. Her class picked the Tongan word for a small, stubborn lamp. The taxonomy committee may not let it stand. They have their own grammar. But 180,000 children in 40 languages have argued about what to call an animal that lives where no child will ever stand. And the light itself, since you ask, in total darkness at the bottom of a trench, it is a clean, cold blue. It lasts about as long as a human breath. What I wish people understood is that it does not feel alien when you are there. It feels local. It feels adapted. The shock is not that life has managed to survive without our sky. The shock is how completely it has built a world of its own. Life does not need our sky. It never has.
Aisake Tuita, microbial ecologist at the University of the South Pacific, thank you for bringing the bottom of the ocean into this studio.
Thank you, Paula. It is good to talk about the dark places as if they are ordinary, because they are.
The consortium catalog is public this month, and the follow-up observations on the 42 light-year signal are expected through the northern summer. I'm Paula Reese. This has been the Apotheora Conversations. We'll see you next month.